Thank you, Jamari. Thank you. All right. So I think we all got the recursive and the explicit equation for number 4. Does anyone need me to go over that at all? Okay. We all good?
Yes, sir.
Now, I do want to remind you, I'm not going to go through the whole thing, but when we talk about a recursive equation, how does a recursive equation always start?
F n equals F times n minus 1.
Be careful, not f times n minus 1, f of n minus 1. That's also function notation. F of n and f of n minus 1, because the current value is equal to the previous value. So what am I doing to 2 to get to 3? Doing to 3 to get to 4.5.
Multiplying 1.5.
And some of us wrote as 3 halves or multiply by 1.5. Either way works. Is that enough, though, to define that recursive?
No.
You always need that starting point. And what I want to remind you of is that right there, that recursive equation is more than enough to write an explicit equation every single time. If you know what the recursive equation is, you can write an explicit. Because when we do an explicit, f of n is no longer the current value. What is f of n in the explicit? What does an explicit equation relate?
Current inputs and outputs.
Or an explicit is all about inputs and outputs. F of n, is that an input or is that an output? Remember, you plug in and you get f of n. You plug in, but f of n is what you're getting out. Does that make sense, though? Okay. I'm not your little bro. Show respect to your teachers. What is the starting output, though? 2. And then what are we doing to it? Multiplying by 1.5 or 3 halves. N minus 1 times, which most of us got there. What I really want to talk about is number 5, because 5 traditionally trips a lot of students up. McKay, you did not like it at all at first, did you? What details did you notice about number 5, though, to make it a little bit easier? Okay, so f of 3 equals 10, f of 7 does equal 26. And I do think you put it on a table maybe. I think Donovan did the same thing, where he did 3, 10, and 7, and 26. Now, one thing I want to point out is, Linnea, originally, what did you think the common difference here was?
16.
16, right? But what is the issue with that? We're missing, well, only 3 terms, 4, 5, and 6. But that addition of 16 is over how many terms? What would you just say, okay? So we're only missing 3 terms, but we went from 3rd to 7th, so how many terms is that 16 over? It is over 4. For those of us who already figured this out, what is my common difference here? Common difference is 4, which, remember, common difference is the same as what other additive rate of change? What's another word for a common difference?
Slope.
Slope, right? Which slope is my rise divided by my run? My rise was 16. My run was 4. What is 16 divided by 4? 4. And so we could have quickly figured these different values out. Or you could have just guessed and checked. And I saw some of us work backwards to get our first term. I will say this, if you're going to work backwards to get to the first term, why not just go ahead and go all the way back to the 0th term? Because if you have the 0th term, you also have what is called the y-intercept, right? The y-intercept can be very useful. Does that make sense? We go with those ideas? What I also want to remind you of is this. You can also graph it. McKay, you eventually did that, right? 1, 2, 3. The 3rd term was 10, so 2, 4, 6, 8, 10. So the 3rd term was 10. 4, 5, 6, 7, 12, 14, 16, 18, 20, 2, 24, 26. The seventh term was 26. And if it's arithmetic, what shape do we know we have in between? A line, right? A linear shape. So could you have used that linear shape to figure out where the other points were? Right? The first term was at 2. The second term was at 6. Fourth term was at 14.
I don't know.
You see how I could have used that linear shape to fill it in. Notice that's not using the table. It's just, hey, I know it's arithmetic, so I know it's linear. Multiple ways to approach this. Does that make sense, how we can see it in different ways? And so I don't want you to ever think, hey, I have to make a table, I have to make a graph. You see which one's easiest for you. We good with those ideas? Okay, so what recursive equation did y'all come up with?
F of n equals f of n minus 1 plus 4.
Okay. So, is McKay correct that we're repeatedly adding 4 every time? Yeah? Is that the full recursive equation? What do we still need? A starting point. Now, honestly and personally, I would say 2 different starting points would be the easiest thing here. You could very easily have said f of 3 equals 10. Then you wouldn't have had to go backwards in the table at all. Does that make sense? Or, because you did go backwards, I would have looked at f of 0 equaling negative 2. Either one of those would work. And it doesn't matter which one you do. I think some of us did f of 1 equals 2. Okay? And I want to show you something useful and important about going from this recursive to an explicit. F of n, is that my input or my output? When we're talking about explicit, that's my output. So when I look at this starting point, what is my starting output? 10. Then what am I doing to that 10 repeatedly?
Adding 4.
See how we're adding 4 to the previous? So plus 4, how are we going to mathematically show repeated addition? Multiplication by what?
N minus 1.
Not n minus 1 this time.
N minus 3.
N minus 3. Notice how we started the third term this time. Let's look at the second one down here, because I think this is what a whole bunch of y'all did. If I'm looking at f of 1 equals 2, what's my starting value now? 2. And then what am I doing to that 2?
Adding 4.
Adding 4 times n minus 1 this time. Please pay attention to this, because this can make your job in life easier to understand the connection between these things. I'm going to distribute. What is 2 minus 4?
Negative 2.
Here, I'm going to distribute. What's 10 minus 12?
Negative 2.
So even though they look different, are they the same? And what was my y-intercept?
Negative 3.
So I'm starting at negative 2 and then repeatedly adding 4 n number of times. So I want you to see it doesn't matter what starting point you choose. They're all the same equation. They're all the same function. You just have to identify, hey, what's my starting output? What am I repeatedly doing to it? And then it's a little bit more straightforward from there. Does that help tie the recursive and the explicit together a little bit better? Do we understand why we can do it with any starting point? Okay. Donovan, you didn't like this one to start, did you?
No.
No! Why not?
I don't like shape.
You don't like shapes. They're so dastardly. Right? But let's look at this one, alright? We're running low on time, so we're just going to do a few of these together. When I look at number 6, try to find, I know that the sequence is a model for the perimeter of the following figures. How am I supposed to start on this one?
Count.
You got to count, right? Because for figure 1, what is the perimeter?
6.
6? Now, I want to point this out. Hey, gentlemen, I need you paying attention. I want to point this out for that figure 1. The easiest thing to do, and for all the figures, is I would mark through the sides as you count them so that you don't make a mistake. So figure 1, there are 6 sides, or 6 is the perimeter. When I look at figure 2, first off, how many of you think there's going to be in figure 2?
14.
So 14, did anyone else think anything different? Did anyone think it was going to be 18?
Hold on.
Huh?
How do you get 6?
I thought
Right.
that.
How do you get 6?
1, 2, 3, 4, 5, 6. It's 6 sides. The length of each side is 1. But Caroline, you were originally thinking 18, right? Because 6 times 3 is 18. And Donovan, you were originally thinking 18, didn't you?
Yeah.
However, and this is what Donovan realized in Linnea too, 1, 2, is that a part of the perimeter?
No.
So do I count it? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Notice there's 2 here that we're not counting, there's 2 here that we're not counting. That's 4. 18 minus 4 is 14. Alright, now I will say, I'm going to run into a little bit of trouble here if I don't start organizing my information. Does anyone know a mathematical way to organize information? Any guesses? The table? Could we use a table to organize what's happening? Okay. So I'm going to use F and P. Does anyone want to take a shot in the dark while I'm using F and P here?
Figure.
Right? Figure and perimeter. I always try to use variables that make sense in the context. So for figure 3, I counted 22. Does anyone know of a way that I could have made that easier instead of just counting every side? What would you multiply here though? Say again? 14 minus 6? So, well notice, and this is kind of what we were talking about here, originally you thought it would be the 6 times 3, the number of figures, or the figures, right? But then here I took away how many? Took away 2 here and 2 here. So here it'd be 6 times 5, and then subtract how much?
6, 8.
So that could have sped things up, right? And that does give us our 22. So those are things that we want to pay attention to. How can we simplify our process? But now we need to look at this table. Does anyone know anything new based on this table? What? Plus 8. 14 minus 6 is 8. That was an ugly 8. 8. 22 minus 14 is 8. So we have a common difference of 8. Come on, that should immediately tell me something else. If it's got a common difference, if it's got an additive rate of change, it's called an arithmetic sequence. Alrighty then. What else do I definitely want you to be able to do from here? What is one of the most important things that we've been trying to write this whole time? Recursive and explicit equation. What would the recursive equation be? F of n equals 6 for a recursive equation? Huh?
I think it's 8.
So it is plus 8. But how does a recursive equation always start? F of n
I'm
equals,
talking about the split.
right, f of n equals f of n minus 1, because the current value is equal to the previous value. We've got to keep that in mind. You've got to know the difference and identify the difference between recursive and explicit. If you don't, it will bite you in the butt tomorrow. You've got to study this. So what am I doing to that previous? Zay, I have everything I need for this equation?
Yeah. No.
Why not?
What it cost?
What did Caroline say it's called? Do we need a starting point?
No.
Remember, what is this only defining? The what? Not the input and output.
Current and previous.
Well, it's showing how the current and the previous are related. But what is this plus 8? That's the what for this function?
Common difference.
The common difference, which is a
Rate of change.
rate of change. Please remember, this always defines the rate of change, and that's it. The relationship between the current and the previous defines the rate of change. That's all it does. So you still need where that function started. F of 1 is equal to 6. Once you know both of the rate of change and the starting point, then you can more easily write the explicit equation. And this is what Donovan originally tried to start with, right? Because where does this function start? It starts at 6. Then what's happening? Then we're adding 8. We gotta remember, because we're repeatedly adding, we're gonna multiply. Make sense? Okay. Really quick note. That was number 6. Is this 7? Yeah. You'll notice I skipped number 9, 8 to 10. Number 9, they messed up on. Like, go look at number 9 really quickly. If they only tell you that the first term is -2 and the fifth term is -1/8, and that's all they say, more than likely it's geometric, but they don't tell you enough information to know that. So I skipped number 9. The reason I bring this up is you don't have to do all these problems, but I will be uploading the solutions for the rest of this tonight so that you can try it on your own and think through it. Don't put your stuff up yet. Because number 8 is one that students regularly miss. I know that the sequence models the value of a car that originally cost $26,500 but loses 10% of its value each year. Is this going to be geometric or arithmetic?
That's a geometric.
When it's a percent of, what does a percent of always do? It multiplies. We need to recognize that. However, it's losing 10%. Does anyone know what the common ratio would be in this case? Because as soon as I read this problem, I know my common ratio.
0.10. 0.9.
Why would it be 0.9 and not 0.10? What percent of the value do you start with?
1.
Well, you start with 100%, right? You start with the entire value of the car. But every year, what percent of the value are you losing? So what percent are you left with? You need to recognize and remember that with percentages, you always start at 100%. And if you gain, you're doing 100% plus whatever the percentage that you're gaining. And if you lose, you're taking it away. I can guarantee you there will be a question like that on your test tomorrow. You need to remember when it's a percent of, it's geometric, it is multiplication, so 100 minus that 10. But if it's gaining, it's going to be 100 plus something. That was also on your understanding check. You have no homework tonight except for to study for your 9 weeks test. I would make sure that you try the last 4 problems and you check your solutions. I will have them up before I leave school today. And I'll send a notification out on Schoology. Say it again? So 4.
Come on, come on.
Hello, girl.
I'm gonna go.
Hello.
Gonna go.
What are you doing?
Hey Anthony, how's it going?
Hey, yeah.
It's going.
What's up? What's up?
Are we actually doing things today?
Yeah. At least you're not complaining like my previous class. They came in, they're like, Mr. Kinney, we're doing stuff? Oh, you're the worst. And I was like, yes, I am. I'm aware.